Did you know you can install Redis using Docker in just a few steps, or that there is an open source GUI for Redis called Redis Insight to help you manage your data? And Redis isn't just a cache layer, it can persist data and even function as a standalone database. It can also play a key role in authentication and other critical app functionalities. In this video, I'll show you how to set up Redis with Docker, use Redis Insight for easy database management, and properly integrate Redis into your Node.js application using the Facade pattern. I'll also walk you through real-world examples from my own projects to show you how Redis can be a game changer. Let's dive in. First, let's look at how to install Redis, and I'm going to be performing these steps on a cloud Ubuntu server. And to install Redis, first you need to install Docker. So here is a link where you can find the instructions to install Docker. Let's first copy this command and run it. Hit Y whenever you receive a prompt, confirmation prompt. Then you need to run the next command. Let's copy that and paste it. Hit enter. Hit Y again. That's it. Docker is installed. Let's clear the terminal. To verify that Docker is installed, we can verify with the command docker ps. Perfect. So Docker is now installed. Now let's install Redis. Again, we want to persist the data so that we don't lose any data when the server is restarted. So to achieve that, we need to first create a dedicated volume and then mount it at the time of server creation. So let's look at the steps. So first I'm going to create a dedicated volume with the command docker volume create. Hit enter. That's it. Redis data volume is created. Now this is the command to start the Redis server. Let me break it down. So we use docker run in -d means in detached mode so that the terminal is freed up. Then we do a port mapping. Redis by default runs on port 6379. So we also map it to the same port on the host. And then I want to specify a name to this container called redisdb. And then we're going to mount the volume that we just created to this path inside the container. And then we want to persist the data, right? So we can achieve that by passing the argument append only yes. So when you pass append only as yes, whenever you write something to the Redis database, the data is stored on the disk. That way, whenever the server is rebooted, you don't lose the data. And finally, I just want to set a password of 123456, and if you hit enter, that should first download the image because it's not available locally. And in a few seconds, perfect. Redis is installed. So we can verify that with the command docker.ps. You can see that Redis was created 4 seconds ago and it's running. Now let's look at the steps to create Redis Insight. Now here is the command to install Redis Insight. Again, Redis Insight doesn't require a dedicated volume because it's just a GUI pointing to Redis server. So there is nothing to persist. And we're going to run this in detached mode and do a port forwarding of 5540 because Redis Insight runs on port 5540. And then I'm just going to give it a name called Redis_GUI. All right. And let me put a space here after the name argument and hit enter. That should download the Redis Insight image and create the Redis Insight container. That's it. Redis Insight container is created and you can verify that with the command docker ps. Perfect. So now that Redis and Redis Insight both are created, let's open Redis Insight in the browser and add the database. So you can just go to the browser and open the port 5540. And my Ubuntu server is running on this IP address, and that's when you can access Redis Insight. For now, I'll just agree to the terms and conditions and hit submit. That should log you in. And now you can add a database, the Redis database that we just created. And if you hit connection settings, you can just set the password as 123456. And it's already running on 6379 port when we did the port mapping and add Redis database. You can see that it gives me an error when I map it to the local host IP address. So when you get this error, you can add the local IP address of the Redis database, which is 172.17.0.2. And you can get it with this command. Again, I'll leave all the commands in the description box. And when you add it here and save it, just call it redisdb. That should now be saved. Perfect. So that's how you add the Redis database, and you hit open the Redis database. You will see all the keys to the left hand side and the values on the right hand side. As of now, we don't have any values because we just created the database, but this is how you can use Redis Insight as a GUI for Redis. All right, now let's verify persistence. So previously when we created the Redis database, we created a dedicated volume and then mounted it, and also used append only flag so that the data is stored to the disk every time we add some new data to the Redis database. So let's verify that. So let's add a sample key. Let's add just some sample data. So I just want to add just a simple key value pair. So I'll say verify and dk hub Let's hit add key. Okay, so as you can see, we have a key and a value. Let's add a hash map as well. So I'll just put a hash map value as, let's say, Binance, and enter some values. I'll just say symbol BTC USDT and hit add key. I can also add more values. I'll add, let's say, interval as 1 hour. Again, I'm just adding random values just to verify that the data is stored. All right, I think that's it. Let's reboot the server and see if the data is persisted. So let's go to the terminal and run the command sudo reboot. And you can see the session terminal got disconnected immediately. Let's wait for a few seconds and then reconnect and see if the data is still available. All right, the server is rebooted. Let's first see if the containers are running. Docker ps -a. You can see that the containers are not running. They exited 2 minutes ago. So let's start the containers first and then verify whether the data is still available. So first, let's start the Redis database. We can do it with the command sudo docker start and the container ID. Perfect. And now let's start Redis inside as well. Now let's run docker ps again. Perfect. You can see that the services are running. Now if I go back to Redis inside in the browser, you can see that the database is still available. When I hit open the database, you can see the values still exist. So that's how you achieve persistence. A quick tip here when it comes to managing the containers. So when we rebooted the server, we had to restart the containers again, but you can avoid that step by passing the restart always flag at the time of creating the servers so that the containers are automatically restarted when you reboot the server. So this is how you achieve persistence on your Redis database. Alright, now let's look at how to interact with the Redis database in your Node.js applications. So we have a package called io-redis that we can use to interact with the Redis database, and we're going to use Facade pattern to implement this module in your Node.js application. Again, you can read more about Facade pattern, Facade design pattern. I'll leave a link to this in the description box. To just summarize what it is, the way I'd call Facade pattern is define once and use it everywhere in your application. So what I mean by that is you'll create a dedicated module with this io-redis package, and wherever you want to use Redis within your application, you'll refer to this module. Let's say in the future, there are several advantages by using this approach. So the first thing is, let's say in the future, you want to replace io-redis with some other package. Then you only have to modify the single module. You don't have to, if you did not use this pattern and you have io-redis sprinkled all over your application, then it becomes very difficult for you to modify it, right? You have to modify a lot of file. But because we choose to implement with Facade pattern, we only have to modify just a single file, even if we have to replace io-redis with some other module in the future. And second, because we are only writing it once at one place, you also tend to write better code. So you don't repeat yourself, right? There's something called dry code, so where you don't repeat yourself. So because you're writing all the functionality in a single module and using it everywhere in a code base, your code is more reusable. And third advantage is that you can control the number of connections you establish with the Redis server by using this approach. So in this case, we are only going to establish a single connection with Redis server, but there are some cases where, let's say you're using a Postgres database, then what you generally do is you create a pool of connections and then rotate between those connections to load balance your queries. That's how you make your queries performant if you use Postgres database. But in this case, when we use Redis, we don't need to do that. We just create a single connection and reuse that for all the queries. And finally, we can also handle graceful shutdowns when we use this approach. So whenever your application is crashed or it gets shut down for some unknown reason, you'll be able to identify that and gracefully terminate your Redis client connection so that you don't run into any issues when you reopen the connections. We'll revisit these advantages once we implement the connection. If it's confusing, don't worry about it. Once we implement the code, all of this will make more sense to you. So let's go ahead and write the code and then understand these benefits in detail. All right, I created a simple project called Redis demo. Let's first initialize a node project with the command npm init --y. Then I'm going to install two packages, which is .env and io-redis. Hit enter. Perfect. Let's close this. I'm going to add the following environment variables, which is the Redis host, which is the Ubuntu server where we're running it, and port number, which is 6379, and also the Redis password, which is just 123456. We used these values at the time of creating the Redis container using Docker command. Now let's create a module called redis.js, and let's also create a main entry file, which is index.js. I'm also going to add a type module key value in the package.json so that we can use ESM syntax. Now let's define this Redis module. So first we'll just import the io-redis package. Then we'll create a client that we'll use to establish the connection and use it in all the queries. Then we're going to have an initialize function where we'll initialize the connection. And first we'll just instantiate this object, client object, and then whenever the connection is established, we just want to log Redis is connected to the console, and when there is an error, we just log it. And also when the connection is ended, we just handle these events inside this function. And then we also create a function for graceful shutdown. So whenever the app is terminated for whatever reason, we just want to call this function so that the connection is gracefully handled. The shutdown is gracefully handled. And we just point this function on all these events. So whenever there's an uncaught exception or network error, whatever, so all these are handled to gracefully shut down the connection. And finally, I just want to create two functions to set some value to the Redis database and also get some key value to the database. We'll add more functions later. For now, I'm just adding these two functions to demonstrate how this works and just export all these functions finally from this module. So this is what I meant by Facade pattern. So we handled the connection and all the queries inside this module so that in the future, if you want to move to another package, we only have to update the single file. And we also have control on how we gracefully shut down the connection and also how many connections we establish to the Redis server. Now let's use this module in the main index.js file and run some sample queries. In the main index.js file, first let's import the .env module to import environment variables, and then we'll create an immediately invoked function expression so that we can handle async calls inside this. This is what I generally do because we don't get global await in Node.js, which is fixed in Deno, if you know, but alright, I'm going off on a tangent, but I digress, but let's get back to the topic. So first let's import all the environment variables and then destructure the Redis host port and password, and then initialize the Redis service by passing this payload, which includes the host port and password. And then after 2 seconds, we're going to set these values, a simple key which says test and connection works. I'll just correct it. And then after 5 seconds, I'm going to retrieve this value and log that to the console just to verify that the connection works and we're able to set some value to the Redis database. I'm also going to import a Redis service at the top. Let's run this and see how this works. So if I run node index, all right, the connection is established, and all right, after 5 seconds, we got the message that the key value is set. Now, see what happens when I close this application. So when I hit Ctrl+C, that should close the app, but you'll also see a command. You will see the graceful shutdown function that we defined in action. So when we close this app, you can see that the graceful shutdown function is called before shutting down the application so that we can be sure that the connection is properly terminated. So that when we reboot or restart this app, a new connection is established. We go to Redis Insight and refresh. You will also find the value that we just added on the database. So this is how you implement IO-Redis package to communicate with the Redis database in your Node.js application. Alright, now let's add a few more functions to the Redis module. So first I want to add a function called setWithExpiry, where you can set a key value with an expiry date so that the value will perish after a certain time. And we'll also include a few more functions related to hash maps. So first is add to hash map. So if you want to set some value, key value to a hash map, you can use this function. And if you want to get all the hash map keys, we can use this function. And next we have get hash map value so that we can get a specific hash map key value. And then we have a function to delete a hash map entirely and also a function to just delete a hash map key. So hash map is like a JSON where inside the hash map you can have multiple key values and also expiry date if required for each key value. So after you define this function, you just need to export these. Okay, we'll add one more function which is get all hash key values, and then we can just export these functions from this module. Let's hit save. Alright, now let's add examples for those functions. So first we'll set a value with expiry. I just want to set a key USA with value Denmark that expires in 10 seconds. And then we just create a new hash map called countries, and we can just add these values as key values. So the good thing about creating a new hash map is you don't need to create the hash map separately and then add key values. You can directly, call the add to hash map function, and once you add a key value pair to hash map, the hash map gets automatically created. Okay, these are just some goofy examples. Then once we add these examples, we'll first get all the hash map keys, all the keys, and we log it to the console. And then we just get a specific hash map value, which is what is Australia. And then we can also get all the hash key values with this function, and then finally we can just delete a specific key in the hash map, and finally just entire hash map. So let's save it, let's run this and see it works as expected. So let's run it. Okay, we set the values, we're able to get these 3 keys. And what's the value for Australia? Upside down, that's what we set. And here is the list of all the keys and values. And then finally Finland is deleted. I mean, just one key is deleted, and finally all the entire hash map is deleted. So all the countries are deleted. Yeah, this is just some goofy message. All right, let's run this one more time to make sure the set with expiry works properly. So we'll go to Redis Insight and verify that this value is set. So let's run it again and go to Redis Insight, hit refresh. You will see a key called USA with the value Denmark that should expire in 2 seconds. Again, it was set 8 seconds ago, so that's why you see 2 seconds. If I refresh now, this value should no longer be available. If I hit refresh, you can see the value doesn't exist anymore. So that's how we can use set with expiry function to store some temporary values in your Redis database. Alright, now that we understood how to implement Redis, let's look at some real world examples. I'll walk you through some projects that I built and show you exactly how Redis was used in those projects. As in some cases it was used as cache, in some other projects it was used to store results of an expensive calculation or some data that I want to share across modules, and it can also be used to store authentication data. So I'll walk you through all those examples in the next section. Let's do it. Alright, here is a code snippet from the TruthCube. Again, you can find the videos for this TruthCube Chrome extension on my YouTube channel. It's just a small extension that helps you analyze YouTube short clips and identify false statements made in that video. So in that Chrome extension, I implemented session-based authentication. Now, when you implement session-based authentication, you have an option to store the cookies in memory. But to make it even better, I chose to store the cookies on Redis. So the reason I did it this way is because in the future, if I choose to horizontally scale the application, so what happens is when you horizontally scale the application, you run multiple instances of the application. So if you happen to store the cookie in memory, then if the user is connected from one instance of the app to another instance, then the user will be logged out because the session is stored locally. But if you choose to store the session on Redis, then no matter which instance of the application the user is connected to, the authentication session will still remain active because the cookies are stored on the Redis server to which all the apps have connected to. So yeah, I mean, this is one example of using Redis to store shared data. This is especially useful when you're horizontally scaling your application. So yeah, I mean, here is how you define the cookie information. So you create a Redis store, and I want to keep the session active for 30 days, and you can pass it in the max age argument, and then I'll take you to Redis Insight and show you the actual value. So this is how the cookies look like. There's an expiry set to 30 days, and after 30 days, the cookie will expire and the user will be prompted to log in again. So yeah, this is how you can use Redis to store cookie information to implement session-based authentication in your web app. And this makes your application horizontal scaling proof. So yeah, this is a better way to handle cookies. Now, here is another code snippet from the same Chrome extension. So I have a route called add payments, and here is where I accept payments from PayPal. And whenever you initiate a PayPal payment, you need to get the access token from the PayPal server. But the good thing is this access token is valid for up to 1 hour. So you can actually cache this access token and reuse it so that you don't have to make an API call to PayPal server all the time. So this is another example of using Redis. So in the route, I first try to get the access token from the Redis server. So only when the token is not available on the Redis server, that's when I make an API call to the PayPal server and retrieve the access token and then cache it with expiry. That way you can reuse the access token on subsequent requests. So this is another example of using Redis to cache reusable data within your web application. I also want to show you the Redis module that we implemented using the Facade pattern. So if you look at the examples that we visited earlier in the previous section, I've used a same approach in the add-in as well. So whatever I explained earlier is exactly how it is implemented in the extension as well. So you can see that I have an initialize function, and this is where I create a connection and handle all the events. And I also have these helper functions that I use throughout the code base. Facade pattern is not just limited to Redis package. This is an approach that I use for almost all the third-party packages that I use, like Axios or GOT for handling API calls. So whenever I'm I can use a Facade pattern. I tend to go with this, so I tend to use this pattern a lot in my code base. Here is another example that I use Redis for. So let's say I want to distinguish between free tier and pro tier, and I want to set some rate limits. Then instead of setting them as environment variables, I can set those as configurations, as key value pairs on Redis. And because we already achieved persistence, even when the server is restarted, these values are not modified. Now, the advantage with this approach is, let's take this, right? Let's say for the free tier, when I initially started the project, I want to set the K-line limit to, let's say, 10,000 candles, or I want to set the number of streams to just 10 streams, and duration is 86,400. So 86,400 is like, that's how many seconds are there in a day. So I use this to calculate rolling window limits. So what I mean by rolling window is, let's say somebody is consuming your API right now, and we just take the last 24 hours from the current time and enforce these values. So rolling window is a better way to enforce limits. So let's say in the future you want to change the limit from 10,000 to, let's say, 11,000. You can just modify this value, and you don't have to restart your application or change the environment variables and all that stuff. So this makes it convenient, and you can also store this in the table, but generally you tend to store collections or tabular data in a database, right? This is just configuration, so you only have a single instance of this data. So storing it on Redis makes it easy to modify in future without having to restart your applications. Here is another example of using Redis. This is from the project Volatility Grid, a project that I recently launched on my channel. Again, you can find a link to all these projects on my website, dkhub.com. So here you can see a key value called Binance Spot Markets. So here is where I store all the pairs that belong to a particular market and cache them. Again, you need to get, this is from the Exchange Data API call. Again, if you are familiar with the Exchange APIs, they have a certain limit. So you cannot just make infinite number of calls. So it's a better approach to cache the results, and these values also don't change so often. So a better way to handle this data is to cache the results on Redis and reuse the information. So that's what I did here. So I implemented Volatility Grid for Binance futures and Bybit spot market. So you can see for Bybit spot, these are the values, and for Binance futures, these are the market. So I have the market and the corresponding pairs for that market. And I also stored the Volatility Grid results for all the pairs on Redis, and you can find the values over here. So every time the values are calculated, those are cached to Redis. And whenever a new user connects to the website, to the Volatility Grid link, the values are served from the cache. Just to give you an example, if you go to Bybit spot and USDT market, these are the values, right? So this is the dashboard. So if I want to show you a value, so if you look at Atom USDT, these are the values, right? So if I can go to Redis Insight, and if I go for Atom USDT, wait, I have to click show more because I need to show more again. Let's see if we get it now. Yeah, we found the results. So these are the values, and these are delineated with a comma. So each value indicates a value for a particular time frame. If we go to the dashboard, where is Atom USDT? Yeah, on the daily time frame is minus 4.4%. So if you go here, you can see it's minus 4.37. So which is rounded off to 4.4. So this is how the values are served on the dashboard using Redis. That's it. So these are some real world examples of how you can integrate Redis within your web applications. That's it for this video. Let me know if you want me to make detailed videos on the real world examples that I covered in this video. Again, I think when it comes to features, I barely scratched the surface. Redis offers a lot of features, a ton of features that even I didn't get to fully explore. Just to give you a few examples, Redis offers a PubSub system that you can use to implement PubSub publish and subscriber model, and Redis also supports time series database. So there are a lot of other features that Redis offers that that can be handy and help you build scalable web applications. Let me know if you want me to make more videos on Redis, and I will talk to you in the next one. Bye.